In this video 6.6, we are going to be solving inequalities by multiplying or dividing. By the end of the video and work time in class, you should be able to say, I can write and solve inequalities. So I want to start by looking at this first number line and graphing the solutions x is less than 3. So if I place 0 here in the middle and 3 then would be to the right, if x is less than 3, it would be an open circle, just like we talked about in the previous video, and anything less than 3 would be shaded to the left. Now in this next example, on the second number line here, I want to look at the opposite of x is less than negative 3. And so the x isn't alone here, so I would need to get rid of, which right now in front of that would be a negative 1. And to get rid of the negative 1 that is being multiplied by the x, I'm going to divide both sides by negative 1. And so then I would get x is less than 3. Okay? So then if I were going to graph that, it would look exactly like the number line that I had shaded above, anything less than 3. But now I want to check the solution here. So what is less than 3? How about 2? We know that 2 is less than 3. So I'm going to take the original inequality we had, the opposite of x is less than negative 3. And we're saying that for our solutions that x could be anything less than 3. So I'm going to erase this x and I'm going to put in 2. So negative 2 is less than 3. No, 2 is not a solution because negative 2 is not less than negative 3. It's greater than. Let's just check one other value for x that we have shaded here. How about something less than 3, like, how about, let's just say negative 4. So if I put in negative 4 right here, what happens, this becomes positive, is 4 less than negative 3? No, so x could not be negative 4. So what we're doing here is not working. What's shaded is not accurate. What I want to show you then is I'm going to erase all of this work, even the graph, because the graph is wrong. It didn't make the inequality true. Coming back over to the problem, when I divided both sides by negative 1, what I had to do was say that x, I had to reverse the sign, is now greater than 3. Because what we're doing here is dividing both sides by a negative. That's making everything the opposite. So that means you have to reverse the sign to the opposite of what it was. So now our graph, it's open at 3, but greater than 3, we would shade to the right. So now if I pick something that is shaded, like 4 would be shaded. So our original inequality is the opposite of x is less than negative 3. So I'm going to replace the x with 4. Now it's true. If I replace that x with 10, that's true as well. So what I'm trying to show you here is whenever you have to divide both sides by a negative, you have to flip the sign. And the same, whoopsies here, my microphone just almost fell off. And the same is true for multiplication, the opposite of division. If you multiply both sides by a negative, you have to reverse the sign also. And so that's the property I want you guys to write down. Multiplication and division properties of inequalities. When you multiply or divide each side of an inequality by a negative number, you reverse the direction of the inequality sign. So in this problem, example number 1, we have y divided by negative 4 is greater than 3. So we want to get the y alone, so we have to get rid of division of negative 4. Opposite of division is multiplication. So we're going to multiply both sides, because whatever we do to one, we do to the other. We're going to multiply by negative 4. Because it was being divided by negative 4, we're going to multiply by negative 4. Now this simplifies to 1. So y, but now we have to reverse that sign because we're multiplying both sides by negative. Everything is now reversed. So now go from a greater than to a less than sign, and 3 times negative 4 gives you negative 12. So your solution would be anything less than negative 12. I'm going to place 0 here. So negative 12 is to the left. It'd be open because it's not included, and less than would be shaded to the left. And so you could pick an example like negative 20. Negative 20 is shaded, so put negative 20 in for y. Negative 20 divided by negative 4 gives you 5, and 5 is greater than 3. Negative 5 times b is less than or equal to 15. So to get the b alone, we're going to undo multiplication of negative 5. We're going to divide both sides by negative 5. This simplifies to 1, so b is alone. Reverse the sign, and then 15 divided by negative 5 gives you negative 3. At negative 3, this would be a closed circle because it says b is anything greater than or equal to. So with that or equal to, that means you're going to shade it, and greater than would be shaded to the right, and shade all the way to your arrow. Plug something in to just make sure that those are the true solutions. So we're going to plug something in for b. Let's say 5, because 5 is shaded. Negative 5 times 5 gives you negative 25, and that is less than or equal to 15. You have to also be able to take a word problem and set up the inequality and then solve it. A small business sells each CD of its game software for $12. How many CDs must they sell to meet the goal of at least $84,000? So they want to make $84,000 or more. So they want to make greater than or equal to 84,000, and then they'd be satisfied. They make $12 per CD. So when we solve this, we would divide both sides by 12. We would not reverse the sign in this problem because we're dividing by a positive. It's only if you're dividing or multiplying both sides by a negative where you reverse. So this would stay greater than or equal to. You don't reverse it here. 84,000 divided by 12 is going to be 7,000. So at least 7,000 CDs is what they would have to sell to make 84,000 or more. Can you say, I can write and solve inequalities? Here's your output for your notebook. Be prepared with any questions for the work time in class.